All right, this is the really quick version of chapter 3.1. I got to get done in 15 minutes. So here we go. Essentially what we're talking about today is classifying triangles. This is a triangle because it has three sides. That's what makes it a triangle. All right, the endpoints are called vertex. It's a vocabulary word you need to know. When I say vertex, you think endpoints. All right, the sides, we have opposite sides are across from their vertex. So if this is my vertices A, then it's the side opposite is also called A, or it's the side opposite to A. We have adjacent sides are any sides that are connected by a vertex. Opposite is across from the vertex. Adjacent means they're connected by a vertex. Put this in here because I love Calvin and Hobbes. Congruent triangles. Two triangles are congruent when all three angles of one triangle are congruent to all three angles of a second triangle, and all three sides of one triangle are congruent to all three sides of the other triangle. So basically, all the parts are congruent in some manner. So corresponding angles. Notice how A is in the lower left and D is in the lower left of its triangle. They correspond to each other. C corresponds to F and B corresponds to E. They're in the same location on the triangle. We call them corresponding angles. Now, corresponding sides is the same idea. Notice how AB is the long side, DE is the long side, so they correspond together. And if we say triangle ABC is congruent to triangle EF, then we say that those two sides correspond. AB corresponds to DE. All right, a congruency statement. When you write a congruent statement for two polygons, always list the corresponding vertices in the same order. So ABC is congruent to PQR. Because A is a single line, P is also a single line. So we have to do A first, then P has to be first. Well, then we went to B. B has three lines. Which one has three lines? Q. So we say PQ. And then we look at C has two, R has two. So we went from 1, 3, 2. We find the new triangle. 1, 3, 2. It's got to be in the same order. Notice P, B, and C are there. A, B, C, P, Q, R. And then we say AB, segment AB is congruent to PQ. Segment BC is congruent to QR. And then AC is congruent to PR. These are the corresponding parts of these triangles. So when you get a congruent statement like this, you know a ton of information. You know angle A is congruent to angle P, angle B congruent to angle C, and segment AB is congruent to segment PQ. You've got lots of information given to you. All right, so this is on a test. Okay, you have to know this. CPC-TC, corresponding parts of congruent triangles are congruent. All right, so if I have congruent triangles, right here, congruent triangles, and they are congruent, then their corresponding parts are congruent. Just remember CPC-TC. That's what you have to remember. This is an actual test question. All right, so far, any questions? We're moving on. Triangle sum theorem. All right, all the angles of a triangle add to 180. Pause, read up on this triangle sum theorem. We've covered it 3 times already. They add to 180. Exterior angles. Exterior angles are outside of a triangle. If I extend the line longer, then this becomes an exterior angle. Interior angles. Well, that's just what we think of as the regular angles of a triangle, but we have to specify interior and exterior when we have them. See how here the lines don't extend? It's just a triangle. If I extend the lines out, then suddenly I create exterior angles. And so when I do that, I have to also indicate interior angles are inside. All right, now here's the exterior angle theorem. This is kind of cool. The exterior angle of one part of a triangle, you got this part, number 1, is equal to the red angle added together. If I add both those angles together, I get the exterior angle. So let's look at an example here. Find the value of x and y. X is in the middle there. I don't really have any information about it. I don't have that they're parallel. I don't really have anything at all. But I can say, hey, look, there's an exterior angle. If I draw the triangle in red, right there, and then I extend this line out in green, I can now see that the blue angle is equal to the two interior angles. That's the exterior angle theorem. See how that works? All right, now I go on and I say x now equals 110. If I tell you that, you've got to be able to say that's from combining like terms. That's just algebra. Now we're looking at y. Y has the same scenario. It's got the triangle and it's got the extended side out. It's got this extended piece right there. So x literally equals y plus 45. Okay, so I plug in, I do some substitution or transitive property. Either way works. And we do some algebra, and we use the subtraction property. Great proof of why x equals 110 and y equals 65, using just the exterior angle theorem. So right here we've got example 3.2, and we're going to go fast. So plan through this. I tell you that this is true. Well, that's just telling you that all of the angles of a triangle add to 180. Triangle sum theorem. Notice how the 40 plus the 20 makes that whole big angle of that green triangle. Then I say combine like terms, and then I subtract 150 over, and I've got y equals 30. Now that I have y equals 30, I can look at this triangle over here and say, again, triangle sum theorem. All the angles of a triangle add to 180. I substitute in for y, and then I combine like terms, and I subtract 140, and I say x equals 40 because of the property of subtraction property. Either way, all I used was this sum theorem twice. And then I did algebra, combine like terms, and went down the way. All right. Classifying triangles by their sides. We have three different kinds. Scalene, where all three sides are different. We have isosceles, where two sides are congruent. And then we have equilateral, where all sides are congruent. If we classify them by angles, we can say if it's acute, then it's got all three angles are less than 90 degrees. If it's a right angle, then one of them is a right angle. If we say obtuse, then one of the angles is bigger than 90. And our last one is equiangular. It's the same thing as equilateral, but instead of a lateral pass, like in football, a sideways pass, we're talking about equiangular because we're talking about the angles being the same. So now isosceles has a base and two legs. The base of an isosceles triangle is the side of the triangle that is not congruent. The two legs are the congruent sides. The legs of an isosceles triangle are the two congruent. A right angle has a hypotenuse and two legs. The hypotenuse is the big word for the big side. If it's the big side of the triangle, then it's called the hypotenuse. Vocabulary word, know it. It's also the side that's opposite from the 90-degree angle. All right, now here's an example. We have name the triangle based on length of the sides. All right, so I have here two sides that are congruent. So I say they are isosceles. There we go. Name the triangle based on the measures of its angles. So that one's 100. We know that isosceles, let's see here. I've got acute, nope, they're not all less than 90. Equiangular, no. Right, no. 100. It's bigger than 90. That makes it have to be obtuse. All right, now name the legs of an isosceles obtuse triangle. Legs are the ones that are the same. So we're going to say AQ and QZ. They're the legs of the isosceles triangle. This is vocabulary words, memorize them. Legs are AQ, ZQ. Now it says name the base of the hypotenuse. The base or hypotenuse. That's the one that's not equal. So we just say it's AZ, not congruent. There we go. Now here's example 3.4 from the notes. We are going to go ahead and say name the triangle based on the length of its sides. All three of them are different. What do we call it when they're all different? It's called scalene. Remember how it looks like it's leaning one direction? And yes, I said one direction for a reason, because of the band. Just kidding. Scalene is leaning. All right, now if we measure it based on the angles, I see it has one right angle, so I call it a right triangle. So this triangle is literally called a right scalene triangle. Or now we got to name the legs. The legs of a right triangle are the non-long side. They're the short legs. All right, right there, 3 and 4. We say the legs are RB and BY. Now I want to ask you for the hypotenuse. Remember, that's the long side. The longest side there is 5, so it's RY. All right, so congruent statements give us lots of, we talk about AC and PQ being equal. It's because they have to line up. So now if I complete the congruent statement below, RKM is congruent to NPM. So R corresponds to N. So we put angle N there. Don't forget the symbol. Now P corresponds to K because they're in the same position. And then M corresponds to M because they're in the same position. See how those arrows are pointing to the same location? Don't forget the symbols. That will help with 13 through 15. Now here, MP. Notice how MP, the only one that happens here is MP right here. That corresponds to MK. So we put MK. Don't forget the symbol, and don't forget to go in the right order. Now, KR. K starts here and ends here. The color symbols means blue to red, so we'd say PN. And then NM goes to RM. All right, that's going to help you with the homework. So now we've got triangle MRK. Ooh, MRK. We start with M, we go to R, and then we go to K. That takes us from M to N to P. We have to keep them in the same order. Now, PNM, here's the next one. We start with P, go to N, and then M. So over here, we have to start with K, go to R, and then M. So it's blue, red, green. Here we got to go blue, red, green. Hopefully that helps. Bonus, KMR. KMR corresponds to blue, green, red. Blue, green, red. Should be PMN. Do that one on your own. It's a bonus. Now you know enough to do the homework. Right now we're going to go on. Congruent statements. If I give you all of this, can you tell me congruent statements? This is something you can work on your own. It's a little bit of a project. We're going to talk now about the third angle theorem. If two angles of one triangle are congruent, then the two angles of another triangle, then the third angle are also congruent. That's an extension of the transitive property and the triangle sum theorem. But just know that if these two, A and B, are congruent to D and E, then guess what? C and F are also congruent. All right, so this is a big, long problem. We're going to try and get it done in the next time we've got. 3.6. If I give you that they're parallel, the reason given is because it's given. And I mark it on the diagram. Now I say my reason is given. My next piece of information I could do all of the givens right now, but instead I want to look at EAB and EDC. Those angles are congruent. I mark them on the diagram, and then I say that they are because of alternate interior angles. I can go on more. I can say ABE is congruent to DCE. Again, mark on the diagram, alternate interior angles. I could also look at AEB and CED as being congruent, mark on the diagram, and I say they're vertical angles. I say AB is congruent to CD. Look where it came from. It came from the given. Now it says that E is the midpoint of DA and DC. So midpoint, that's given. It's the midpoint. That means they're congruent by the definition of a midpoint. Now again, we see the same thing. It's the midpoint of BC. That's given to us. They're congruent because it's the definition of a midpoint. So we put in definition of a midpoint. Now look at that. I have shown that two triangles are congruent. And the reason being, definition of congruent triangles. Right there. All three angles are equal to all three angles. All three sides are equal to all three sides. That is a huge problem. The order on this could have been done in any order. You could have given all of your givens first. You could have built all this later on. It wouldn't have mattered. As long as you get three angles are congruent to three angles, and you get three sides are congruent to three sides, and you tell me the reasons behind it, then you're good to go. All right, this should help you on your homework. You should be able to accomplish it now. Fill in your summary and your notes. A lot of people aren't doing that. Make sure you fill it in. And if you watch this before class, that would be awesome because it's done now. So there you go. Oh, I just started the timer. Ha! Awesome. Do the summary, do your homework, do your notes, and we'll see you in class.